again, this is Samkelo Xolo. So we're gonna be looking at a question related to rates. Number one, as you can see from the screen, which reads that a NASA rocket that is launched vertically from the Earth is tracked by a radar station located on the ground 3 kilometers from the launch site. The distance between the radar and the station rocket can be accurately measured using a radar and used to calculate the speed of the rocket. The question is, show how to calculate the vertical speed of the rocket the instant that it is distant from the radar is 4 kilometers. Radar measurements show that the distance from the radio station to the rocket is increasing at 3,000 kilometers per hour at the instance when the rocket is 2 kilometers from the radio station. That's the question. Yeah, so from that information we were able to carry on and do a sketch of the situation which shows the rocket away from the radar. Yeah, so this is the radar station. This is the Q, the distance between the radar and the rocket. This is the X, 3 kilometers away from the launch site, and the Y is also looking for a change in Y. And then it's also given that the change 2 kilometers away from the radar and the rocket, it is 3,000 kilometers per hour, and then X is constant, 3 kilometers. We're looking for a change in Y, so we're gonna start by looking for Y. So this is our first thing. So to get Y, what we're looking for, we're gonna use a Pythagoras theorem like this. So we know that x is a constant, so the change in x is 0, but we also know that the change in q2 is 3,000, so change in q 3,000 kilometers per hour. So we're gonna use Pythagoras to find the y at that instant. So the Pythagorean theorem works and gives us a y which is a root of 5. So it's the square root of 5, which is the value of our y. So the big question is, what is the rate of change in y when the rocket is 4 kilometers away from the radar? So this is our question. So we go on and use the similar to Pythagoras, but it's about the rate of change. As you can see, it's very similar. So there are coefficient between them, which is x times dx dt plus y times dy dt is equivalent to q times dq over dt, but I didn't include them here. But you can see below, you can see that x, as I said, x is a constant. It's distance between the size of the launch and the radar station, so it's constant, so it becomes 0. And we solve for y, remember, so the same y we're gonna like multiply the rate of change in y with the same y, and do the same thing with 4, the same 4, which is the distance between the rockets and the radar. Now at this instance we are doing this calculation, so it's on 4, but we remember that we were given the value of dq over dt to be 3,000 kilometers per hour. So we're gonna just substitute the value to the forgive me. As I was saying, we're gonna sub the value into the expression to the equation, and we get something like this. So from here we're gonna divide by the square root of 5 both sides to get dy dt. Dy dt is 5,366.53 kilometers per hour, and this is the speed at which the rocket is going vertically upwards when the distance between the radar station and the rocket is 4 kilometers. That's all. Thank you.